Hey everyone, welcome to Math 100. We're working on section 2.6 today on the least common multiple and equivalent fractions. So we're going to find the least common multiple. We need to know what multiples are. So the multiples of a number are what you get when you take a number and multiply it by 1, 2, 3, 4, 5, and so on. Those give you all the multiples. So the multiples of 3 would be 3, 6, 9, 12, 15, and so on. The three dots are called ellipses. They mean that the pattern continues. So if you want to list out the multiples, you could just write out a comma-separated list, and then when you get a certain number of numbers into it, then you just put another comma and three dots, and that means goes on forever. Your turn number 1, find the first 8 multiples of 6. So if we multiply 6 by 1, we get 6. By 2, we get 12. By 3, we get 18. By 4, we got 24. By 5, we get 30. By 6, we get 36. By 7, we get 42. And by 8, we get 48. So there are the first 8 multiples of 6. So we're going to need to find the least common multiples of sets of numbers. We're usually going to be working with 2 numbers. Sometimes it'll be 3. So what we're going to do to find the least common multiple, which is the smallest matching multiple between these lists that we're going to create. So to find the LCM of 8 and 12, we're going to write out lists of the multiples of both 8 and 12, and then find the smallest match in those lists. So for 8, we got 8, 16, 24, and I usually just like to write out a couple and then go to the next one and then see if any matches occur. And there's the first match at 24, making the LCM equal to 24. Your turn number 2, find the LCM of 4 and 6. There's our multiples of 4. Counting by 4s, we got 4, 8, 12. Counting by 6s, we get 6 and 12. So first match is at 12, so the LCM is 12. A little bigger numbers now, 10 and 16. So I'm going to write these out. We got 10, 20, 30, 40, 50, 60. Let's try 16. 16, 32, 48, 64, and 80. So we're going to need a couple more on this list. I'll just write them up here. 70, 80. So there's our first match, making the LCM of 10 and 16. 80. Your turn number 3, 12 and 20. Multiples of 12, we got 12, 24, 36, 48, and 60. So if you look at the pattern here, notice that the tens digit goes up by 1 every time until we have to carry, and the 1 digit goes up by 2 each time. So when you're writing out multiples like that, it can be helpful to see patterns like that. All right, so LCM is 60 between these two. Now we're going to look at a special case. And in this special case, the LCM ends up being one of the numbers because one of the numbers is a multiple of the other number. So that's why it's very important when you write out these lists of multiples to make sure you include the first one. Make sure that you include the number itself. Some people skip over that one. You have to write that first one. Because now we see that 24 is a match. If you don't write that first one, you're going to go right to 48. And you're going to have to go out to 48 on this one, then you're going to have to reduce your answer. And so it's a lot more work that way. So make sure you get the least common multiple. All right, your turn, number 2. Oh, no, not number 2. We are on number 4. Find the LCM of 7 and 49. So 49 is a multiple of 7. So 49 is our LCM. All right, now next example, another special case here, and this is a big time saver. And this is one of the reasons it's important to be able to recognize prime numbers. So if we get 2 prime numbers, the least common multiple is automatically going to be their product. So just multiply them together. All right, since 3 and 11 are prime, multiply them together to get 33. The LCM is 33. And this will also shorten the procedure for creating equivalent fractions with the LCM as the denominator. So being able to recognize prime numbers and remembering this special case, it's a big time saver. Your turn, number 5. Find the LCM of 5 and 7. Multiply them together, we have 35. 35 is the LCM. So we can use this technique to find the LCM of any number of numbers. We're going to go out to a maximum of 3 in this course. So next example, we're going to find the LCM of 10, 16, and 20. So we're going to write out all 3. So we write that out. We're going to look at these lists and find the first time we see a number in all 3 lists. It has to match in all 3, and the first time that happens is 80. So that means the LCM of 10, 16, and 20 is 80. Your turn, number 6. Find the LCM of 6, 8, and 12. We have the list of multiples. First match is 24. Now we're going to look at finding the least common denominator. The procedure is exactly the same, but we're going to be presented with fractions instead of just numbers. Alright, so if we want to find the LCD of two fractions, we're only concerned with the bottom numbers, the denominators. Alright, least common denominator. Don't worry about the numerator. So we're going to do 15 and 20. So write up the multiples just like we did before. And our first match is 60. So that means the LCD equals 60. So what we're going to work on then is transforming both of these fractions to have a denominator of 60. Your turn, number 7. Oops. There. Alright, so for 15s, 15, 30, 40, 50, 60, 75, and 90, 18s gets us also out to 90. So that makes the LCD of those two fractions 90. So just like the numbers, we can apply this technique to any number of fractions. So next example, we're going to work on 3 fractions. We're going to find the LCD of 7 eighths, 5 twelfths, and 4 18ths. So right now, a list of multiples. First match is at 72. That brings us to your turn, number 8. Find the LCD of 5 sixths, 3 tenths, and 7 twelfths. Alright, there's our list of multiples. First match is 60. So that is our LCD. So this will be the first step when we build fractions. Alright, so as we've seen, we can take any number and multiply it by 1 and we get the same number. So we don't change the value at all. And we've also seen we can write any number over itself and that equals 1. So that's what we're going to be doing. We're going to be taking a fraction and multiplying it by a number over itself. So it changes what it looks like, but it doesn't change the value. Alright, so we take any fraction, we can multiply by 1, doesn't change anything, still equal. And then we're going to rewrite 1 as some number over itself. I'm just going to call it C for right now, because we don't really know. Then we get a new fraction. It's going to look different, but have the exact same value as the one we started with. So first example, we're going to take the fraction 3/5 and make the denominator 20 without changing the value of the fraction. Alright, so what are we going to multiply by? What's the C going to end up being in this case? Alright, to find that, we take the new denominator, the one we want to have in the fraction, and divide by the old denominator. 20 divided by 5 gives us 4. So 4 is our multiplier. So we're going to take this fraction 3/5, multiply by 4 over 4. That gives us a new fraction, 12 over 20. Now if you were to take a calculator and do 3 divided by 5, you're going to get 0.6. If you do 12 divided by 20, you get 0.6. So same value, it just looks different. Your turn, number 9. Write the fraction 4/7 and build it to have a denominator of 21. Alright, take our new denominator, divide by the old one. 21 divided by 7 gives us 3. So 3 is our multiplier. This works because addition and multiplication and division are opposite operations. 4 times 3 is 12. 7 times 3 is 21. So 4/7 is the same as 12/21. Next example, we're going to build 2/9 to have a denominator of 54. Alright, we're going to get something over 54. So let's take 54, new denominator, divide by the old one. 54 divided by 9 is 6. So 6 is our multiplier. So we'll take 2/9, multiply by 6 over 6, and get 12 over 54. I know most of the time we go ahead and simplify fractions when we get an answer, but in this case, don't simplify or you'll be right back where we started. Your turn, number 10. Build 5/13 to have a denominator of 65. All right, take the new denominator, divide by the old one. 65 divided by 13 is 5. So there's our multipliers. We're going to do 5 over 13 times 5 over 5 and get 25 over 65. Now we're going to use these techniques to actually build the fraction. And we're going to build two fractions that have the same denominator. So we're going to take, in this next example, 2/3 and 7/15. Make them have the same denominator. So first thing we need is the least common denominator. So let's take a look at those two denominators. We're going to write out our multiples until we find a match. Right, the match is actually the second number. So this is one of those cases where one number is a multiple of the other. So the LCD is the larger number. Now, there's a trick we can use to figure out what to multiply by. You can do what we did before. We can take 15 and divide by 3. Or you can just count over. Here's the first multiple, second, third, fourth, fifth. 15 is the fifth multiple, so you multiply by 5. So we take 2/3 times 5 over 5 and get 10 over 15. So there's our new fraction with 15 in it as the denominator. Now the other fraction already has 15 as the denominator, so that one stays as it is. And there's the one we need to change. So 10/15. Your turn, number 11. 5, 6, and 124. There's our first multiple. First multiple of 24 is the match. All right, now we're going to transform 5 6, and this is the 1, 2, 3, 4th multiple over. 5 times 4 is 20. 6 times 4 is, 24. 20 over 24. And the other one is all set. Already has 24 as the denominator. Next up, we're going to do 2/3 and 4/11. So this is another one of our special cases. Because if you look at the two denominators, they're both prime numbers. So to find the least common multiple, just multiply them together, or least common denominator. That's going to be 33. Now this is when you get these prime denominators, it's a really nice special case because what we're going to do now is just multiply each fraction by the other fraction's denominator over itself. So 2/3, we're going to multiply it by the other fraction's denominator, which is 11, over itself, 11 over 11. Multiply straight across, we get 22 over 33. And for the other one, 4/11, we're going to multiply that by the other fractions denominator over itself. So 3 over 3. Or 12 over 33. Right, so there's our two fractions built to have the same denominator. Your turn, number 12. 3/7 and 4/5. Again, we have two primes in the denominator, so multiply them together and get 35. And we'll take this first fraction, and we're going to multiply this one by this denominator over itself, so it'll be 5 over 5. Give me is 15 over 35, and then over here we got 4/5. And multiply this one by this fraction's denominator over itself, so 7 over 7. Give me is 28 over 35. Next up, we've got 7/12 and 3/16. No primes in these denominators, so we're going to have to do it the long way. There's our first match. We got an LCD of 48. Now to transform the first, alright, when you're going to count over 12, you got 1, 2, 3, fourth multiple, so 4 over 4. 28 over 48. And for the second one, we're going to take 3/16 and multiply by, count over, 1, 2, 3. Third multiple, 3 over 3. So that's 9 over 48 and 28 over 48. Your turn, number 13. We're going to do 5/6 and 7/8. First match in those two listed multiples is 24. So there's our LCD. For 5/6, 6 is, you're going to see 24 is the 1, 2, 3, fourth multiple of 6. So we'll multiply by 4 over 4. Get 20 over 24. Now we'll transform the second one, 7/8. And 24 is the 1, 2, third multiple of 8, so 3 over 3. 21 over 24. So there is our two fractions with a common denominator. Next up, 3/18 and 7/30. There's our multiples of 18 and 30. First match is at 90. Transforming the first one, 90 is the 1, 2, 3, 4, fifth multiple of 18. So we're going to do 5 over 5. Giving us 15 on top. And for the second fraction, 7 over 30. 90 is the third multiple of 30. And that gives us 21 over 90. Go to number 14. Two ninths and 7/15. $45 is the LCD. For 2 ninths, 45 is the 1, 2, 3, 4, fifth multiple of 9. Multiplied by 5 over 5, we get 10 over 45. And for the second fraction, 7/15. In this case, 1, 2, 3, third multiple of 15, that gives us 21 over 45. Now, just like we saw before, this technique can be applied to any number of fractions. So we're going to do a couple with 3 fractions. 5/6, 2 ninths, 7/12. First match in all 3 lists is 36. So there's our LCD. So we're going to take 5/6, multiply by 1, 2, 3, 4, 5, 6. That gives us 30 over 36. Got 2 ninths. 1, 2, 3, sorry, fourth multiple there. It's 36. Multiply it straight across, we get 8 over 36. And finally, we're going to do 7/12. 36 is the 1, 2, third multiple. And we get 21 over 36. Go turn number 15. Three fourths, 1/6, and 3/8. There, we got a match at 24. So 24 is the 1, 2, 3, 4, 5, 6th multiple of 4. Multiply by 6 over 6 to get 18 over 24. Second fraction, 1/6. 24 is the fourth multiple of 6. Multiply by 4, we got 4 over 24. And finally, 3/8. 24 is the third multiple of 8. So we're multiplying there by 3 over 3 to get 9 over 24. So this procedure that we've developed today is going to be the first step when we start adding or subtracting fractions together. So this is one of those skills that absolutely is essential for going forward. So make sure you master this one.